In this movie, you learn about compounds, which are essentially subgraphs designed to simplify redundancy in your MCG tree layouts. To learn about compounds, you'll be creating a new modifier that constrains an object between two others. It's a bit like using the position constraint tool that works at an animation controller level, but here you use it as a modifier. You'll need a few objects to work with. Open the scene named compounds.max you downloaded for this tutorial. It shows a bolt and a nut and a simple washer that you need to constrain between the two. The pivot points are set in the center of the nut, washer, and the bolt head. Go to the Max Creation Graph Editor. You start building your graph using the base operators you know you need. You know you need two input nodes for the master objects, in this case the nut and the bolt. From the parameters section, drag in two inode operators. Name them Object 1 and Object 2, or maybe Master 1 and Master 2 if you prefer. Here, you may want to add a validity check. It would serve as a check test that the two master objects are properly selected and prevents any errors in the script. Press X and search for operators beginning with check. You'll find one named Check Node Validity. Go ahead and select it. Use Shift Move to duplicate it, as you need one for each master object. Go ahead and make the connections. Drag out the value output socket and look for operators based on the word node. Since you're mainly interested in the master object's position, choose the node position operator. Repeat for the other master object. At this point in the design of the graph, you're basically duplicating the branch for both master objects. Ultimately, the washer is dependent on the position of both master objects in space. In order to constrain the washer between them, you need to add these positions together and then divide them by 2. You'll need an add operator, and you'll need to wire the two vector positions of the master objects to it. To divide these position vectors by 2, search for the word divide and choose the divide by scalar operator. Feed the added vectors into the V vector 3 socket and temporarily set the amount to a constant value of 2.0. You change that later. The graph so far caters for the two master objects, but you still need input from the bottom of the stack, input about the actual object you want to constrain. In this case, we're talking about the washer, which is the object you want to apply the modifier to. To collect info from the bottom of the modifier stack about the selected geometry, you need to add a modifier try-mesh operator. You can search for it or drag it from the implicit parameters section. To control the transforms of the selected mesh, you also need a transform mesh operator. Search for it using the X key, which is often easier than browsing through the categories. Wire the mesh data together, the modifier try-mesh value to the transform mesh input. You still need to define the actual transform value, which is based on the tree you created a moment ago. However, note that the master object's tree output ends with a vector, whereas the transform mesh takes its feed from a matrix. If you tried to wire the two together, it would not work. You need a translation operator between the two. Search for that word and add a translation matrix so you can wire the sockets properly. You're almost done. All that's left is to add an output modifier operator to bind everything together. Save your graph and name it MCG _ position constraint Again, the MCG prefix is meant to make it easier to find in the modifier list. Press Ctrl E to evaluate the graph. Select the washer and go to the Modified panel. Note that you have a new MCG-based modifier. Go ahead and apply it. Select the two master objects and note that changing their positions affects the position of the washer. Note that the tool doesn't explicitly move the washer between the two objects, not yet anyway. You still have manual control over the position of the washer. You'll adjust that in a moment. First, you take a look at creating a compound, which is really what this tutorial is all about. Look at your graph, mostly at the section related to the two master objects. You will be compiling the midsection into a compound or a subgraph to simplify the layout. Select the middle section, all the blue operators and the orange constant operator. Right-click and copy them to memory. Now right-click the tab section and create a new view, and then paste the operators in with a right-click. Add an output compound operator at the head of that graph. Also, you need two node operators at the tail of the graph to generate input sockets for the compound. Select the two node position operators and with a right-click choose Generate Inputs. Rename the inputs Node 1 and Node 2, or Object 1 and Object 2 as you see fit. Choose Save As. So far, you have been saving graphs as .maxtool files. There is also an option to save .maxcompound files. Name the new compound MCG_constraint between two nodes, and make sure you save it in the compounds folder. You can give the file any name you want, but we'll stick with the MCG_prefix naming convention we have set up. Go back to your original graph and move the operators you used to develop your compound. In order to access any new compounds you create, you need to reload the operators. Next, use the search box to search for MCG, and you will find your newly designed compound. Select it and add it to the window. Instead of using 6 individual operators, you can now reroute your tree through the compound, resulting in a much simpler graph. In fact, you can even delete the old operators, as you won't need them anymore. Save your graph one more time and press Ctrl E to evaluate it again. If you want to be sure the new graph is behaving as before, delete the existing modifier and reapply it. Test the results. They should be identical to the previous behavior. Next, you need to negate the washer's transforms to make sure it relocates between the two master objects. For that, you need another implicit parameter operator named modifier matrix. Go ahead and add it to the graph. This represents the transform space of the selected object at the bottom of the stack, in this case the washer. You need to convert that space into the space defined by the two master objects. For that, you need another existing compound named mesh in local space. Search for it using the X key and add it to the graph. Link the modifier matrix value to the matrix input socket of the new compound. Next, you need to reroute the graph through this new operator before you output the final modifier. Save the graph and evaluate it again. Note that the washer is indeed between the two master objects, and that you cannot move it anymore. Its position, however, is still dependent on that of the nut and the bolt. Congratulations, you have learned to create a graph and a subgraph in the form of a compound. Editing the compound at this point would update the final graph. As an example, go to the constrained compound graph you created and add a lerp operator. Lerp enables you to specify a linear interpolation between two vectors by defining an amount value. Here, you will use it instead of the add, divide by scalar, and constant operators. Go ahead and delete those and reroute the graph through the lerp operator. For the amount input, use an input single operator and name it weight. Save your compound and go back to the main graph window. Reload the operators for good measure. You'll notice the new weight entry in the compound operator. Add a parameter single to it and set the limits from 0.0 to 1.0 with a default value of 0.5, which represent the halfway distance. Change the name to weight : this name represents the label that you see in the command panel. Save and evaluate your graph. Test out the modifier to ensure it's behaving as designed. Granted, this modifier is not particularly powerful, not when compared with animation constraints. It was only meant to showcase how you can build compounds by putting operators together to simplify graph creation. Feel free to come up with your own ideas and share them with us if you can.